Right, today I'm going to show you how to operate the VTI, which is a Texas Instruments calculator simulator. On this simulator I've got the sheet metal programs loaded. So let's start up the program. Double click the VTI.exe. This will open the calculator. We switch the calculator on. I'm already in the bend program. So you can see here that the program's prompting for the bend diameter. So we'll enter the bend diameter as 500. These dimensions are in millimeters, of course. So then press enter. Center radius, I'm going to enter 850. And again press enter. This bend requires minimum 7 segments plus start and finisher. Start and finisher equals 1 segment, so that's 8 in total. This isn't set in stone, but it's a good guide. So I'm going to go for 8 and enter again. Swage allowance, for this I'll add 6 millimeters. Enter. Lap each side. I normally add 20 mil for a bend of this size. You can, if the bend's small, you can add 10, 15, whatever you wish really. Okay, 20 millimeters, here we go, enter. Now this is asking if you want to split the bend up into 12 or 24 pieces. Sorry, 12 or 24 divisions I should say. I'm going to go for 24 because it's quite a size, this bend. Again press enter. You can see the graph now starting to make a diagram of the template. The plate length will be 1611, that's including the lap at each side. The plate width for one complete bend will be 1629. And the divisions, 24 equals 65. So let's press enter again and go to the next screen. Okay, we can see here from the centre line, from the centre line, 89 up and 89 down. Number 1, from the centre line again, 96 down, 96 up. Then just follow the sequence. 2 is 102, so, and blah 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 blah. Press enter again, go to the next screen, gives you the rest of the sizes. F equals 65 millimeter. F is the throat, so as you can see here. And that's the bend. Pressing enter will take us back to the main menu. From here we can select another program. You can either use the big blue button to scroll up or down, or you can add the program's number or letter that's alongside it, and that'll take you directly into the program. I'm going to put in 7, then enter. Sorry, don't need enter. And this will give us the oblique cone program. Now there's a sub menu in here. You've got 3 options. One is about the oblique cone, gives you a bit of info, not a great deal, just a little bit of background on the oblique cone. Enter again, you go back to the sub menu, press 2 and you go into the main program, the pattern layout. Here you can see the 2 views, the plan and the elevation for the oblique cone, and the cursor is flashing, prompting you for the base diameter. As you can see, the base diameter is the larger of the 2 diameters, so I'm going to enter 500 and enter. Top diameter, as you can see, top's as smaller of the 2 diameters, so I'm going to enter 250 and enter again. Now the cursor is prompting for the length. I'm going to enter 1000 and enter. And then the program will then prompt you for dimension Z. Dimension Z is simply the difference between the 2 centres. So I'm going to go for 250 in this instance. And enter again. You see here the program's graphing out the rough shape of the template. And here we see 1, 2 equals 65. Those are the smaller chords on the top of the cone. And AB goes 131, AB, CD, BC, CD, EF, etc. These are all 131. These are the larger chords around the bottom of the cone. And here you can see A1 equals 1000. 1B equals 1020. Simply follow it through in that sequence. B2, 2C, C3, 3D, D4, 4E, E5, 5F, F6, 6G and G7. There's the rest of the sizes. Okay, that's the oblique cone layout. That will, of course, will give you a half pattern. Repeating the process in reverse will give you the other half of the pattern. Or you can simply cut that out and flip it, whichever's easiest for you. Pressing enter again will take us back to the main menu.